All right, here we go. Section 7.2. We're going to take a look at applications of sets using Venn diagrams or applications of Venn diagrams. We're going to take a look at using Venn diagrams, those pictures we talked about at the end of 7.1, to solve some set problems. Okay? But before we can get to solving the set problems, we have to define some things and work from there. All right, so Venn diagrams and basic sets, applications using Venn diagrams. Some terminology, regions. A Venn diagram is a picture that divides a universe into regions based upon sets, intersections of sets, and so forth. Okay? So a Venn diagram is divided into regions. As more and more sets are added to the diagram, more and more regions are formed. For example, a one-set Venn diagram has two regions. Region 1, Region 2, because this Venn diagram here, this first one, only has one set in it, set A, inside the universe. Now, this notation that we'll be using here, this R sub 1, R sub 2 business, the Region 1 and Region 2, as far as I can tell, and I've never been able to find any definitive rules otherwise, there is no set way to number these things. So calling this outside piece R1 and this inside piece R2 is not about saying that the outside piece is always R1, the inside piece is always R2. What we're saying is there's two regions. Call one of them 1 and the other one 2. I'm going to try to stick to the notation that the book uses. And you'll notice that whether it's a one-set Venn diagram, a two-set Venn diagram, or a three-set Venn diagram, they consistently label the outside Region 1. And then as we add more sets, we get more complicated. When there's one set in our Venn diagram, we just have Region 1 and Region 2. When we have two sets, we now have 4. When we have 3 sets, we now have 3, 4, 5, 6, 7, 8 regions in that Venn diagram. Okay? So the numbering or the ordering of these regions is not standard. Every textbook and every instructor could use different notation. Some use this R notation. I've also seen some people use Roman numerals. So they would call this Region 1. They would call this Region 2, just as a way to differentiate. Okay, but basically what we're getting at here is Venn diagrams break the universe up into pieces, and we label them so that we can talk about them, so that we can properly identify what it is we're talking about. Okay. All right, so for example, what I would like to do is I would like to shade the region of the Venn diagram for the following set operations. So over here on the left, I have B intersection A complement. So that means I've got a two-set Venn diagram. I've got a set A and I've got a set B. Now using our standard numbering, we're going to have a Region 1, a Region 2, a Region 3, and a Region 4. Okay. And I'm supposed to find B intersection A complement. And here's one way to do this problem, not the only, but one way. B is Region 3 and Region 4 in that picture. A complement is Region 1 and Region 4. Remember, A complement is the stuff not in A, so outside of the A circle is 1 and 4. And then my job is to find the intersection of those two. And so what do they have in common? Well, what they have in common is Region 4. So if I were to come over here and shade just Region 4, that piece right there would be B intersection A complement. Okay. All right, moving right along. B union A, I'm sorry, B complement union A. So again, another two-set Venn diagram. I've got A, I've got B, I've I've got region 1, region 2, region 3, region 4. B complement is going to be region 1 and region 2. A is region 2 and region 3. If I take the union of those, I'm looking for all 4 of those pieces lumped together, and region 2 is twice in there, so I won't have to highlight it twice, but I need to shade region 1, region 2, and region 3. So region 1, region 2, and region 3. So basically I want to shade everything outside of region 4. And then that would be, and I'll shade that in so it looks better, that would be B complement union A. All right. How about B union A complement? Well, another 2-set Venn diagram. A, B, region 1, region 2, region 3, region 4. B is 3 and 4. A complement is 1 and 4. The union of those is going to be 1, 3, and 4. Region 1, region 3. So everything outside of region 2. So all of this. It's not too bad. I can do this. Okay. Now I have no idea why this one's centered and not over to the left like the rest of them, but it is. A complement intersection B complement. Okay. A, B, region 1, region 2, region 3, region 4. A complement is going to be what? 1 and 4. B complement is going to be 1 and 2. The intersection of A complement and B complement is just region 1. So it's just going to be the outside piece of this. So I'm using a Venn diagram. Now if I knew what the elements were for the universe for A and B, I could place these elements in this Venn diagram and then just say that the intersection that I've shaded green there for those 2 complements, and then whatever elements were in that region would be the answer to the intersection problem. So Venn diagrams are a nice simple way to draw a picture. Now they get complicated as soon as you have 3 sets. Because now I have to draw a 3-set Venn diagram. Well, the 3-set Venn diagram has 3 sets in it. Now I know region 1 is on the outside, but how they label the rest of it is completely random. So I'm going to go back and look at the picture, and it looks like they do left top to bottom, kind of. Okay. So that's going to be region 2, region 3, region 4, region 5, region 6, region 7, and region 8. And now I got to figure out what this means. Okay, so I'm going to make this as small as I can to see my Venn diagram. Okay, so I know that Aunt Sally, order of operations, told me to work from the inside out of the parentheses. So I'm just going to work from the inside out. And I'm going to do this how I do it. I'm going to cheat a little bit and use some non-standard notation. A is 2, 3, 4, 5. And I want to union that with B, and B is 3, 4, 7, 8, And then I'm going to intersect that with C, which is 4, 5, 6, 7. Okay. So we're starting inside the parentheses. The union of those is going to be 2, 3, 4, 5, 7, 8. And then I need to intersect that with 4, 5, 6, 7. And so what do they have in common? Because that's the intersection, not the 2, not the 3. They got the 4 in common, right? They got the 5 in common. I highlighted 6. The 5 in common, and they've got the 7 in common. That's it. So now I need to shade 4, 5, 7. 4, 5, 7. That little weird piece right there, whatever you want to call that shape. That's what we're looking at there for A union B, intersection C. Okay. And then I've got A intersection B, and I got 2 more of these things to do. Whoa, these are going to be challenging. All right, I think I can do this one. Okay, so let's make this one happen. I'm going to change up my pen color. We're going to go with red. And I'm going to draw my universe and place my sets inside of my universe. There's 3 of them because I got an A and a B and a C. I'll call this one A, B, C. I've got my region 1, region 2, region 3. What they put region 4 in the middle, right? Region 5, region 6, region 7, and region 8. All right, I'm going to start over here on the left. Okay, well, can't make it that small. There we go. A is 2, 3, 4, 5, intersecting with 3, 4, 7, 8, union with C complement. Well, if C is 4, 5, 6, 7, then C complement would be everything except for 4, 5, 6, 7. So that will be 1, 2, 3, 8. All right. So then inside of those parentheses, I'm going to take the union of those 2. And so that's going to give me 1, 2, 3, 4, 7, 8, and I need to intersect that with 2, 3, 4, 5, and we'll take a look at their intersection. The intersection is going to be 2, 3, and 4, right? So 2, 3, and 4. So 2, 3, 4. That weird shaped piece right there. I don't even want to try to describe that with words. But there's my A intersection, quantity B union C complement. Okay, one left to do, then we'll call this video done and we'll move on to the actual survey problems. Okay, another 3-set Venn diagram. I'm going to switch to purple this time. 3-set Venn diagram. A, B, C, region 1, region 2, region 3, 4, 5, 6, 7, 8. Okay. They want us to do, what do they want us to do? They want us to do, A complement. So A complement, that's going to be everything outside of A. So not 2, 3, 4, 5. So 1, 6, 7, and 8 intersected with parentheses B complement, B complement. B is 3, 4, 7, 8. So it's going to be 1, 2, 5, and 6. Union with C, and C is 4, 5, 6, 7. Okay, so this is going to be 1, 6, 7, 8. Intersection with, when I union those, I just lump them together and make one big set. So that's going to be a 1, a 2, 4, a 5, a 6, a 7. And then when I take the intersection, I'm looking for what they have in common. They got a 1 in common, no 2, no 3, no 4, no 5. I got a 6 in common, and a 7 in common. So 1, 6, and 7. So 1, 6, 7. And then shade all that in. That's a lot to draw. And there we go. 1, 6, and 7. All right. So I'm shading the region of the Venn diagram given what they told me. All right, I'm gonna stop this video here. We'll come back with part 2 of this video where we'll actually start taking a look at survey problems, which I'm sure you'll like because they're word problems and everybody loves word problems. So I'll see you all back here for that.